Hello everyone, and welcome to today's presentation. I'm excited to introduce you to the topic, Introduction to Data Binding in Android. Today, we'll explore how data binding, a powerful Jetpack library, helps connect your UI components directly to your data sources in your app. We'll see how it eliminates the need for fine view BID and manual UI updates, making your code cleaner and more declarative. Plus, we'll discuss its benefits in MVVM architecture. So, get ready to learn how data binding can streamline your Android development process. So, why should we consider using data binding in our projects? Well, one of the main benefits is improved code quality. It makes our code more readable and easier to maintain, which is always a plus. Plus, it helps keep the user interface separate from the business logic, making our code cleaner and more organized. Another key point is automatic updates. When the data changes, the UI updates automatically, so we don't have to write extra code to handle those changes ourselves. This also helps prevent common errors like null pointer exceptions, which can be tricky to track down. And lastly, data binding boosts performance by avoiding repeated view lookups. Instead of searching for views multiple times, it streamlines the process, making our app run more smoothly. Overall, data binding is a powerful tool that enhances both the quality and efficiency of our development process, aligning perfectly with our goal of creating better, more maintainable apps. Let's take a look at how to enable data binding in your project. In your module-level build, Gradle file, you'll find the Android block, and inside that, the Build Features section. Here, you need to set data binding to true. This simple line of code is actually a critical step because it tells Gradle to generate the binding classes for your layouts. These binding classes are what allow you to connect your UI components directly to your data sources, making your code cleaner and more maintainable. Enabling data binding at this stage sets the foundation for more efficient UI updates and reduces boilerplate code. So remember, it's as straightforward as adding that one line, but it unlocks a lot of powerful features that we'll explore later in this presentation. All right, let's take a closer look at the structure of a data binding layout. First, you'll notice that you need to wrap your layout XML with a special root tag called layout. This tag includes the namespace declaration, which is essential for binding to work correctly. Inside this root, you'll place your usual layout elements, like linear layout, frame layout, or whatever suits your design. Now, an important point is that within this layout tag, you can declare variables and imports that will be available for binding. Think of these as the bridge between your UI components and your data sources. And here's a key syntax to remember: the @ notation. This is what binds a UI property directly to a data source. For example, you can connect a TextView's text property to a variable or expression, making your UI dynamic and responsive without writing a lot of boilerplate code. Overall, understanding this structure helps you create more modular, maintainable layouts that seamlessly reflect your data changes, which is at the heart of effective data binding. Let's take a closer look at the generated binding classes that are created through data binding. When you work with your XML layout, in this case, activity main, XML, data binding comes into play by processing your layout file behind the scenes. This means it analyzes your XML and prepares everything needed for efficient binding. What's really powerful here is the code generation that happens next. Data binding automatically generates a class called activity main binding. Think of this as a bridge between your layout and your code. It holds references to all the views in your layout, but more importantly, it provides type-safe access to them. So, instead of dealing with generic view references, you get specific types, which makes your code safer and easier to work with. The key idea here is that you use this generated class whenever you want to inflate your layouts or bind data. Instead of manually finding views, you simply work with this class, which streamlines your code and reduces the chance of runtime errors. Overall, this approach makes your UI code cleaner, more efficient, and less error-prone, fitting perfectly into our broader goal of writing more maintainable and robust Android applications. Now, let's look at how we use data binding within an activity. Instead of the traditional set content view with a layout resource, we actually inflate the binding object directly. This means we create an instance of activity main binding by calling inflate on the layout inflator. By doing this, we connect our layout directly to our activity in a more flexible way. Next, we assign our view model to the binding variable. This step is crucial because it allows us to bind UI components directly to properties in our view model, making the UI more reactive and easier to manage. Finally, we set the lifecycle owner to this, which is our activity. This is important because it enables live data to automatically observe data changes and update the UI accordingly, without us having to manually handle lifecycle events. Overall, this approach streamlines the connection between our layout, view model, and activity lifecycle, which is central to creating a clean, efficient, and reactive user interface. Let's talk about binding expressions and event handling now. When you're working with data binding in XML, you can use @ to evaluate expressions dynamically. For example, you might set the text of a text view to a username with Android text equals @viewModel, username. Similarly, you can control whether a button is enabled based on some logic like Android, enabled equals @viewModel is enabled. One of the powerful features here is conditional expressions. For instance, you can set the visibility of a loading indicator depending on whether data is loading. Using Android, visibility equals @viewModel is loading. View, visible, view, gone. This makes your UI more responsive and adaptive without cluttering your code. Moving to event handling, with data binding, you can bind UI events directly to methods in your view model. For example, for a button click, you can write Android on click equals @viewModel on button click. This approach keeps your UI code clean and separates it nicely from your logic, which is a core theme in modern app architecture. In essence, these binding expressions and event handling techniques streamline your code, making it more maintainable and aligned with best practices. They help connect your UI directly to your data and logic, fostering a clear separation of concerns. Now let's talk about two-way data binding. This technique is really powerful because it allows us to keep our UI and view model in sync automatically. When the user makes a change in the UI, such as typing in a search box, the view model gets updated right away. Conversely, if the view model changes for some reason, the UI updates instantly. The key here is the syntax, which looks like this: @equals view model, search query. The @equals part is crucial because it tells Android to set up a two-way connection. This means data flows both ways seamlessly, reducing the need for manual updates and making our code cleaner and more efficient. Connecting this to our overall theme, it highlights how modern development simplifies state management, making our apps more responsive and easier to maintain. All right, let's talk about binding adapters. These are really useful when you need to implement custom binding logic for attributes that aren't supported out of the box. For example, imagine you want to load images into an image view using a URL. You can create a custom binding adapter like the one here, where we define a function loadImage that takes an image view and a URL string. Inside, we use Glide to load the image from the URL directly into the view. Then, in your layout, you can simply write app, image URL equals @viewModel, image URL, and the adapter takes care of the rest. The main benefit of this approach is that it extends the functionality of data binding, making your code cleaner and more declarative. It allows you to handle complex or unsupported attributes seamlessly, which can really streamline your UI code and improve maintainability. So, overall, binding adapters give you the flexibility to customize how data is bound to views, helping you create more dynamic and responsive interfaces. All right, let's talk about recycler view binding and some best practices to keep in mind. When you're working with recycler view, using data binding can really make your UI updates more efficient and cleaner. Instead of manually finding and updating views, you create your item layout with binding, which allows you to bind your view model data directly. This approach simplifies handling complex UI that depends on dynamic data, making your code more manageable. Now, moving on to best practices, it's a good idea to use view model alongside data binding. This keeps your architecture clean and helps separate concerns. Keep your expressions and the layout simple. If there's complex logic, it's best placed inside the view model. This way, your layout stays straightforward and easy to understand. Another important point is to avoid memory leaks. Always remember to set the lifecycle owner when using binding, so the system can manage the lifecycle properly and prevent leaks. You can also use binding adapters to encapsulate UI logic, which keeps your layouts tidy and your code reusable. Lastly, when it comes to user input fields, two-way data binding can be useful, but use it cautiously. Overusing it can lead to unexpected behaviors or difficulty tracking data flow. Overall, these best practices help you build robust, maintainable, and efficient recycler view implementations that align well with good architecture principles.